Shalom to you. We're going to continue with the arithmetic and geometric sequence part 2. Okay, so we're going to start with solving a real-world application problem. So how this could be applied in real life. So company A pays $24,000 yearly with raises of $1,600 per year. And company B pays $28,000 yearly with raises of $1,000 per year. Which company will pay more in 10 years? So let's compare them. First of all, let's write the equation. Okay, would this be arithmetic or geometric? So if it starts, let's say company A would pay $24,000 plus. It's going to be plus the raise, right? Naturally, you pay whatever they have to pay yearly and then plus the raise. So the raise is 1600 per year. So let's n represent the number of years. So for n years, let's say A of n, if at the beginning, when there is no year added before the first year, it's going to be 0. So there will be no raise. But after the first year, so in the second year, they are going to add, which is the year n is 1, they're going to add 1,600. The second year, so we're going to multiply that by twice. So get that raise each year. So it's going to be the same amount being added. So in addition to whatever they had before each year. So then company B, the number of years, B is going to pay 28,000 plus 1,000 per year, number of years. So if we plug in the number of years, 10, so A in 10 years would pay 24,000 plus 1,600 times 10. So that is 24,000 plus 1,600. So company A is going to pay 24,000 plus 1,600. That would be 40,000. Okay, company B is going to pay 28,000 plus 1,000 times 10. So that's 28,000 plus 0,000. 10,000 new, but that's 16,000 here again. So 28,000 plus 10,000, we get 38,000. Okay, so how much more? Which company will pay more in 10 years? So in 10 years, company A will pay 40,000, company B will pay 38,000. So company A will pay more by then we are going to subtract 40,000 minus 38,000. So we can tell the difference between them. $2,000. That's it. That's a good amount of money. So, but you see now, the company A, they are paying less they are paying 24,000 hands down, and Juan is paying more, 24. So it looks like it's much bigger. So we can look at the money and then go for this one. But on the long run, we see that company A will actually pay more. So these are things we can consider, okay, when making our choices. Okie. So we're going to go on to geometric sequence now. So a geometric sequence is the sequence that goes by multiplication. So to find the next term, we have to multiply. They are connected by a common ratio. Ratio is like a fraction. So because when you go backward, if you're going forward from left to right, you're multiplying a number. If you're going from backward, you're going to divide. That's the inverse of multiplication. So to go from A1 to A2, we're going to multiply by a common ratio, R. To go from A2, we're going to multiply by another common ratio, and so forth. So we are multiplying by a common ratio, unlike the arithmetic, where we are adding a common difference, and so forth. That's geometric sequence. So the pattern is fixed that way. So let's derive the formula like we did before in the arithmetic. So A1 is going to be A1 times this time, times the common ratio. Now, it's going to be exponential. Arithmetic is linear. It's a linear function, so a function of a straight line. So geometric is exponential function, which is like it rises here. So it's going to be to the power 0. So anything to the power 0 is 1. So 1 times A1 is going to be A1. So A2 is going to be A1 times the common ratio to the power 1. So anything to the power 1 is itself. So it's going to be A1 times common ratio. A3 is A1 times the common ratio to the power 2, which is A1 times R2. So if we do what we did in the other one, from here we can see right away when it is second power, the exponent is 1. We don't usually put 1 there. But when it's third power, the exponent is 2. So we can rewrite this as A3 equals A1 times R. So how do we relate 3 to 2? 2 is 3 minus 1 would give us 2. So which would be A1 times R to the power 3 minus 1. So therefore AN is going to be A1 times R to the power n minus 1. Yeah, we can actually just leave it like that. So this is our formula, explicit formula we can use to find any term in the geometric sequence. So write the common ratio of the given sequence, then find the next two terms. Well, so since we know it's geometric, to go from one number to another, 9 is going to be times a common ratio would give negative 3. So we already told it's a geometric sequence, so we're just asked to find the common ratio. So we set this up, just use two numbers there, and then we're going to solve for R, we're going to divide both sides by 9. So the common ratio is, so negative divide positive is negative, 3 divide 9 is 3. So the common ratio is negative 1/3. Now to find the next two terms, all we need to do is just start with the last one and then multiply by negative 1/3. Negative times negative is positive, 1 times 1 is 1, 9 times 3 is 27. So that's going to be 1/27. Then to find the next, we have to take 1 over 27 and multiply by negative 1/3 again, and that would give us negative, so 27 times 3, 27 times 3 is 81, so it's negative 181, and so forth. Okay. So the explicit formula we have already derived, and you know where it came from. So let's solve the problem here. I said write the explicit formula if we are given the whose first term. So first term A1 is 5, and the common ratio R is negative 3. So we can write our explicit formula AN equals, I'll write the general one first, times this time R. I would always like to put R in parentheses. So to remind you, because sometimes people tend to multiply the A1 times R first before they take the exponents. No, you have to follow the order of operation. Okay, so now if we substitute for A1, which is 5, times the common ratio, the common ratio we have now, so we can replace it also. Common ratio is negative 3, and then n minus 1. N remains the variable. So that's the explicit formula we are asked to write. That's it. And then we're going to use it to find the 9th term of the sequence. So if we have AN equals 5 times negative 3, n minus 1. You see, if this is like this, people tend to multiply this. So, but put it in parentheses. So remember that you have to follow the order of operation. So A9 equals 5 times negative 3 to the power 9 minus 1. So A9 equals 5 times negative 3 to the power 8. 9 minus 1 is 8. So evaluate that expression first. So make sure, I'm going to show, hold on, showing my calculator here. So make sure you put, if you type this as negative 3, negative 3 to the power 8. See what that gives you? Negative. Oh no, sorry, that didn't work. Hold on. So if I do negative 3, come on, negative 3 raised to the power 8. Now it works. I say to the power 8. What is going on? I don't know why it's not showing, but anyway, so I want to show the difference though. If you put parentheses and say negative 3, and then close the parentheses and say to the power 8. Okay, look, this one is negative, this is positive. So you want to make sure you put parentheses. If you don't put parentheses, that will give you a wrong thing. Okay. So this is A9 is going to be 5 times 6, 5, 6, 1. So we multiply that by 5, and then we get our final answer, which is 32805. Okay, that will be the 9th term of this geometric sequence. All right, let's do geometric mean just like we did geometric arithmetic mean. Again, geometric mean will be the terms that are missing in with a geometric sequence. So like here, again, we're just going to go right away from here to here. We know we are going to multiply a common ratio. From here to here, we multiply a common ratio. From here to here, we multiply a common ratio. We multiply a common ratio. We multiply a common ratio. The common mistake is people tend to stop here, but you have to get to the number, you know. So to add more. So if you have 1, 2, 3, 4, 5, but we have 1, 2, 3, 4, 5, 6 R's. So the number of missing spaces is not equal to the number of R's. Same thing with the common difference. So keep that in mind. Okay, so we start with -2. We are going to multiply by R. How many times? R times R is 2R times R times R times, no, sorry, it's not 2R, we're not adding. We are multiplying. So it's R times R is R squared. R squared times R is R cubed to the 4th, to the 5th, to the 6th. So it's R to the 6th equals -1, 4, 5, 8. And now we do the algebra. So do not make the mistake and try to add 2. This is not -2. This is -2 times. We are looking at the connection between -2 and this R to the power 6. So it's going to be, it is multiplication now. So we're going to divide both sides by -2. So R to the power 6 equals, we have that -1, 4, 5, 8 divided by 8. Oops. -1, 4, 5, 8 divided by -2. So I get 7, 2, 9. Okay, so now how do we remove the exponent? If it is square root, we just take the square root. So since it is 6th root, we are going to take, since it is the power of 6, we are going to take the 6th root. So R, let me do a different color here. So if we take the 6th root of both sides, so the 6th root we cross as the 6th exponent. So this is going to be, take the 6th root of this. So taking the 6th root is the same thing as taking the exponent of this to the power 1/6. Okay, let me see if I can get a calculator out. Okay, so you see the root here. For this type of calculator, we can have the root, any root we want. We can evaluate it like that. Take the x to the root with the math. Okay, hold on. I'm going to, maybe I need to put the 6th first. 6 and then the root. And then the root is 7, 2, 9. Okay, enter. So the root is 3. This is saying, what number will I multiply itself 6 times and get 7, 3, 9? That's 3. So 3 times 3, 9, 9 times 3 is 27, 27 times 3. Keep multiplying, it's going to get that. And we multiply 3 6 times. So if we do this, if you don't have calculator that can do this directly, we can just do, put that in parentheses, 7, 2, 9, close parentheses, and then we can use exponent. But then the exponent, we are going to do 1/2, fraction. So it's going to be 1 divided by 6, so 1/6. Okay, so we raise it to the power, it's reciprocal. So that is going to give us the same thing. See? So that's a way to go around it. If your calculator cannot do this directly, just use exponent. All right. So our answer here is 3. 3 is the common ratio. So with the common ratio now, we can find all the missing terms, which are the geometric mean. So we do, so -2 times 3. Remember, we are multiplying. -2 times 3 is -6. It's -6. So -6 times 3 -6 times 3 is -18. We have to make sure we get to the end to see that it matches. We keep multiplying 3. So -54. -54 times 3, it's -162. We have -54, -162. -162 times 3, -486. -486 times 3, -1458. So that checks. So we have -486. All right, so that's checked, that is correct. So that's how to do it. Let's do application. Write the explicit formula and then find the n term. But I see we are given the third term and the fifth term, so we have term missing. So we have to find the common difference common ratio first, because it's geometric sequence, and then find the first term. Let's do. So, but we know that when the input is 3, output is 36. So this is our n, this is our an. Okay. Likewise with the fifth one. So, but we need just one to plug in. So we're going to find if this is A3, we have some number here, 36. And then we have A4, and then A5 is 3, 2, 4. So there's only one missing, only the F4 is missing. So we're going to multiply by common ratio twice here. So 36 times, so r times r is r squared, equals 324. So if we divide, again, we are not subtracting here, we're multiplying. So we're going to divide both sides by 36. Divide by 36. Divide by 36. So r squared equals 324 divided by 36, which is 9. So we're going to take the square root of both sides. So the square, we cancel the square root. Square root of 9 is 3. So that's the common ratio. Now we're going to find the A1, which we need to write our equation. So that's AN equals A1 times common ratio N minus 1. So we can take our AN, which is this one, which is 36, substitute. We are looking for A1 times the common ratio, which we found is 3, and N here is N is 3. So 3 minus 1. So 36 equals A1 times, so 3 to the power, 3 minus 1 is 2. So 3 times 3, 3 to the power 2 is 3 times 3, which is 9. So 36 equals A1 times 9. So since they are being multiplied, we have to divide both sides by 9. So 36 divided by 9, it's 4. A1, it's 4. So now that we have A1 and we have our common ratio, we can write our formula, explicit formula. So which is AN equals A1. A1 is 4 times the common ratio, which is 3, and then N minus 1. So this is our explicit formula. And now we can use it to find the 10th term, which is a 10th equals 4 times 3 to the power 10 minus 1. So a 10th equals 4 times 3. 10 minus 1 is 9. So we have to plug into our calculator and then do 3 to the power 9, or 3 times 3 times 3 up to 9 times, so if you can do the exponents. So 3 to the power 9, so A10 equals 4 times 3 to the power 9 is 19683. And then we multiply that by 4. Then we get 78732. Okay. All right, that's that. Okay. Determine if the sequence is arithmetic or geometric, then find the next two terms. Well, we have to try arithmetic first. From the way the fraction looks, we can't tell. We find the arithmetic first. If it doesn't work, we find try geometric. So go by, if it's arithmetic, then negative 7/5 plus a common difference would give the next term, 9/10. So we need to have a common denominator. So first of all, add 7/5 to both sides. So D equals negative 9/10 plus 7/5. But we have to have a common denominator. So we're going to multiply this top and bottom by 2 to have a common denominator of 10. So negative 9/10 plus 7 times 2 is 14/10. So we can add the top now. So the common difference would be negative 9 plus 14. So or 14 minus 9. That is 5. So that will be 5/10. So 14 minus 9. Why did I? Oh, yeah. Okay, that's fine. So which we can simplify. We can simplify this to 1/5, but 1/5, but we see here we have like things, well, either way, I will just do this, or 1/5. So depending on which fraction we are working with, we can use either one of them. They are equivalent. So if we want, we're going to try it because it has to work for all of them. So we're going to try the taking this, the second one, and adding this to all of it. So if we take, see if we get the other one. So if we take negative 9/10 and add the 5/10, what do we get? So since they have a common denominator, so minus 9, we got negative 4/10, which is simplified to negative 2/5, which checks for this one. So if we take that negative 2/5, which is equivalent to this one, so if we take negative 4/10 and add. It doesn't really matter. So, okay, let me use what we have in the sequence here. So if we take negative 2 over 5 and then we add again, so we can use this one since there is the equivalent 1 over 5 you're going to get. So negative 2 plus 1 is negative 1 over 5. Okay. 5 over 10. Oh no, this is not even 5 over 10. That should be, sorry, that's my error. So 10 divided by 5 should be 2. This is 1/2, not 5 over 10. I don't know what I was thinking. This is 1/2, so we can't even do this. So I would use, if I use 1/2, I would just use the equivalence of this 1/5. Or that 1/2. So again, we can multiply this by 2 and multiply this by 2. So that's the equivalence of 4 over 10 plus 5 over 10. This is 1 over 10. Okay, so it looks like the last one. So we take that 1 over 10 and then we add again 5 over 10. But we get 6 over 10, which is simplified to 3 over 5. 2 go into 6. 3 times 2 go into 10, 5 times. So you see, they gave us all the numbers in the sequence, so that checks. Okay. So that means that this is the common difference. It is arithmetic. So it is arithmetic. If any of them fails, then it's not arithmetic. So to find the next two terms, so we're going to take the 3 over 5 and then add on 3 over 5 and then add the 5 over 10. So we can make this 2, make this 2. So that's 6 over 10 plus 5 over 10. That is 11 over 10. And we can take 11 over 10 and add 5 over 10. That will give us 15 over 10. And those can be simplified and so forth. Determine if the sequence is arithmetic or geometric. Again, we can try arithmetic first of all. If it doesn't work, since this is a number, we can just say, okay, negative 7 plus a common difference would give us negative 2. So this is addition. So if we add 7 to both sides, common difference here would be 5. So if we do negative 7 plus 5, we get negative 2. Okay, negative 2 plus 5, we get 3. 3 plus 5, we get 8. So that checks. So it is arithmetic. Arithmetic sequence. So if we keep adding 5, so we do 8 plus 5. Okay, that's 13. 13 plus 5. 18. And so forth. Okay, let's see if we find one geometric. So if we try arithmetic here, we say 15 plus common difference equals 13. So if we subtract 15, common difference is 15. So 15 plus 15 is 30. 30 plus 15 is 45. So that fails. You see the common mistake here. If you don't check all of them, you check 15 plus 15 is 30. Oh, so that's correct. That's it. But see, it doesn't work for the other ones. So you have to check everything. So we know this is not arithmetic. So we have to check whether it's geometric. It could be neither sometimes. So we're going to try geometric. So geometric, we multiply a common ratio. So we say 15 times a common ratio equals 30. And so we're going to divide by 15. So common ratio is 15 divided by that is 2. So if we do 15 times 2 is 30. 30 times 2 is 60. And 60 times 2 is 120. So that checks. That is geometric sequence. Okay, this geometric sequence. So we're going to find the other ones. So 120 times 2 is 240. And 240 times 2 is 480. Okay. All right, that's it. We'll stop here. Okay. Hope we covered everything. So those are the two next terms.